This is Unit 7, video number 9, titrations. So when we're dealing with titrations, we're dealing with a sample of something, normally a solution, so something normally in water, and we want to know what's the concentration of something in the sample. So what we're going to do for titrations is we're going to form a reaction that's going to react with whatever is in, whatever we want to find, determine the concentration of in our sample. So we don't care about what we're producing, we don't care about the product, we're going to compare the reactants together and use them to determine concentration. So the apparatus for titrations is the use of a burette and an Erlenmeyer flask. So we normally put in the burette the concentration of the known reactant. So we know the concentration of this, and then down here is our sample, and we normally find an indicator in there that's going to change a color to let us know when the reaction is complete. And this is kind of the standard titration that we do. So here on the board we've got a little titration reaction. We're taking sodium iodide. It can be used to determine the presence of sulfate in a water sample. If 16.4 milliliters of a 0.15 molar sodium iodide completely neutralizes the sulfate in a 50 milliliter sample, what is the sulfate concentration? So what we care about here is the relationship between the two reactants. So I've given you information for one reactant, sodium iodide, and we want to know what's the concentration of the sodium sulfate. The sulfate ion, because we know when this is dissolved in water, this is going to dissociate, so we can get the concentration of just the sulfate ion. So what we're going to do is first we're going to need to get this into moles, because we know that we cannot compare anything unless it's in moles, so we have to use stoichiometry. So we're going to take 16.4 milliliters. We know that molarity times volume gives us the number of moles. Well, I gave you that the molarity of sodium iodide is 0.150, and I gave you the volume, but in milliliters. We know volume needs to be in liters, so if we get this in liters, it's 0.0164. Okay, if you multiply those together, you get that the moles of sodium iodide is 2.46 times 10 to the minus third. And this is the moles of sodium iodide. What this allows us to do is it allows us to now switch into moles of sodium sulfate. So we know whenever we need to switch to another compound, we're going to need to use the mole ratio. So moles of sodium iodide is going to go on the bottom. If you look at the ratio here, we get it from the balanced chemical equation. There's 8 moles of sodium iodide to 1 mole of sodium sulfate. So we're going to have 8 mole on the bottom and 1 on top. And this is the sodium sulfate. This is sodium iodide. Okay, and when you punch that into your calculator, you get the moles of sodium sulfate to be 3.08 times 10 to the minus 4. Okay. But I don't really care about the moles. What I'm trying to find out is the concentration. So I want to know, what is the sulfate concentration? Well, if I have moles, we remember concentration is the number of moles of solute over liters of solution. So I've given you the volume here. We just determined the number of moles, so if we just divide this by our volume, which needs to always be in liters, we're going to get our molarity concentration. So we'll get that the concentration of sulfate ions to be 6.16 times 10 to the negative third. If you were to just punch that into your calculator, you would have got 0.00616.